everybody. I just flew in last night and I'm pretty jet lagged, so I'll probably lose my train of thought and jump all around and whatever. I apologize for that. Also, these slides are a little bit old. I'm in the middle of writing a book on this subject that I need to finish at the end of this month, and so it's been kind of nonstop. I've been working with who here has read The Phoenix Project by Gene Kim, who's one of the co-inventors of Dora. Yeah? Okay. Yeah, pretty cool book, huh? It was, Anita's talk, shows how far CI/CD has come and how rigorous and disciplined we are. But back when he wrote that book, it was a shit show, if you'll pardon my French. Okay? I mean, it was like everybody deploying everything everywhere at every company, and they would crash and burn, and they didn't understand why they were crashing and burning until Gene and Jez Humble and the Dora team came along and gave us Dora metrics, right? Now, how do you bring science to this? They did a lot of it through surveys, right? Get enough statistical data. So anyway, I'm co-writing this book with Gene, and I'm going to tell you guys a little bit about it and the journey that we've had, yeah? So for starters, why am I even doing this? Why am I even here talking to you guys? I could be kicking back somewhere right now, yeah? I'm pretty much retired. I am working at Sourcegraph doing a bunch of marketing for them because I think their coding assistant is really, really cool and I've worked on it. But, why am I doing this? And the answer is my first job in this industry as a programmer was in 1992, all right? I'm probably the oldest person in this room. And so in that 33 years, I have never seen anything like what I saw when I was an engineer for the first 6 months of last year. I was the head of engineering at Sourcegraph, and I did something that you're going to see as a pattern that you're going to see more and more of, which is senior leaders, tech leaders, stepping down from the role to go back into IC again. And I'll talk a little bit about why that is, but I mean, in short, AI is driving this, yeah? And so I stepped down, and I did it for the same reason. Because I was like, all this AI stuff is happening, and I'm kind of I'm watching, but I'm not in it, right? And I was like, what happens if, 2 years go by and all of a sudden everybody's doing it and I don't know anything, right? So I decided I'm gonna go try this stuff out. I'm gonna try it. And 6 months later, my boss, by the way, Quinn Slack, he's the founder of Sourcegraph. He told me he wanted me to blog one post per week, yeah? So 6 months go by and I haven't blogged at all. And I wrote one blog post that pissed off the entire world. It was called The Death of the Junior Developer. And what I had realized was that there's a really serious problem that's emerging in our industry right now, okay? And it's not just our industry, it's happening in many industries, including legal and writing and pretty much anything creative. Okay, what's happening is, the pattern is, okay, I'm just going to share a story, all right? Gene told me a story about his buddy who's at a legal firm, a law firm, okay? And they've been around forever. They know how to do their stuff. They always hire junior lawyers and then they train them up, right? The junior lawyers do the junior stuff, yeah? Well, it turns out that ChatGPT is so good at that stuff that they only need the senior lawyers to go and review it before a judge sees it so that nobody goes to jail, right? So now they're stuck with this existential crisis because you can't just not have junior lawyers because at some point your company will just all retire and disappear. So how do you get that cycle going again? So after I posted my post, which really did make a lot of people mad, okay, they're like, no! Dr. Nathan Bean, who has been studying robotics and surgery for a long time, reached out and said that he sees the same thing happening in surgery, yeah? He says that junior surgeons, the path from going from a junior surgeon to a senior surgeon has been broken. The circuit is open, okay? And the reason is the exact same thing with the lawyers. The senior surgeon used to have a junior surgeon with them during the surgery to learn the ropes. But now they do all that with robots, and so junior surgeons have no opportunities. This is a serious problem in the medical industry right now, right? So anyway, this is why I'm telling you guys this stuff, because I saw this happening. I saw it happening in programming. Now look, is GPT any good at writing code today? If you sit down and you're writing code, who uses chat to write code today? Here, now. Pretty good number of you, yeah, but not all of you, all right? Who prefers completions, code completions? Completions for. I've noticed that there are completions engineers and there are chat engineers, and never the twain shall meet. The Venn diagrams don't overlap very much. I have a hypothesis about this. Yeah, Zbigniew and I were just talking about how the benefits of AI are uncomfortably non-uniform. That's what we're finding. Okay, we're finding that it helps a lot with some things and it doesn't help at all with other things, yeah? And it varies by the individual and what you know. In fact, it's kind of the case that if you're really, really good at something, like your best programming language, and you're in the middle of a big system that you contributed to and you wrote a lot of yourself, then the chances are you know a hell of a lot more about it than the AI is going to for years, until the RAG systems catch up. So, right? So, where can I go with this? The jet lag is strong, folks. So my hypothesis about this is that if you're really good at something, the AI is not going to help you very much. And most engineers spend most of their day doing stuff that's in their comfort zone. They don't branch out and go to some other team and try to pick up their code base and make a fix to it very often. We do this on purpose. We want to reduce communication and coordination overhead, which was one of the big killers they discovered in Dora, right? AI changes that, because with the stuff that you're not good at, now you're very good at it, right? Right? In a sense, okay? At least you know a hell of a lot more than you would have, 2 years ago, right? It has democratized, senior engineering knowledge, which is great, right? Who here thinks that chat-oriented programming, which is using GPT to write your code and then copying it into your IDE, or using a coding assistant like Cursor, Copilot, Sourcegraph, who here thinks that that's fun? Oh my God, we got a couple of hands. All right, a few. I think it's fun too, but it's so different from regular engineering that most engineers that I know, they're kind of waiting for it to sort of settle before they kind of get into it. Or I was just talking to somebody earlier, Artur here, that your company may not let you use a coding assistant. Like you can't use Cursor, you can't use Copilot. Sell their stock. Those companies are doomed, right? They need to get their act together. All the companies that are dragging their feet on AI right now are in real trouble, all right? All right, so anyway, with that, that's my intro. I'm just gonna jump into this and run really fast through the slides, all right? The task graph. I'm going to zoom down here. I'm going to keep you guys all awake by running around through my slides. This is the best metaphor that we've come up with. We've come up with a few for what's happening here. When you're doing a project with other people, okay, you have a bunch of tasks and they form a graph. Anybody here a project manager? Anybody here a technical program manager? Anybody here lead projects? Come on, some of you do, right? You know this, right? You know that there's dependencies between the tasks. You can't deploy the software until the network is set up and blah, 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 right? And that you flatten this into a directed acyclic graph to get the project done, right? You can't be any cycles or you get stuck, all right? Well, what's happening is right now, coding assistants can help you with some really low-level tasks, yeah? And with chat-oriented programming, you can actually kind of do all of the leaf nodes in the fullness of time. Like chat-oriented programming is really new and the tools aren't very good. The coding assistants, including Sourcegraph's Cody that I work on, none of them, Copilot, Cursor, Tab9, Replit, all of them are terrible at chat-oriented programming, okay? They don't help you with things that you need to know. There is an art to it. You wouldn't think so, but come on, these LLMs are a pain in the butt. It's like a wrestling match. It's like a boxing match trying to get information out of them sometimes, isn't it? Right? No, you're wrong. I heard a really funny thing from the inventor of the Django web framework. He says, the great things about these LLMs is they're like having a crazy intern, okay? Crazy intern. And he said, the funny thing is, they can do all this work and you can just bully them a little bit, right? I hate to say it, but you can say, no, do that again. Do it again. No, that's wrong. That's wrong. And you don't have to feel bad about it, right? It's such a different workflow, yeah? And agents bring us up here. Agents will be able to do more. My belief and Gene's belief, we've thought about this a lot. We've talked to a lot of people and we've played with a lot of agents. Now, other people think differently, but we think that agents are ultimately going to be, first of all, fast feedback loops are going to be more interesting than the ones that go off for 2 hours and disappear and come back with a, a dead weasel in their mouth or something, completely opposite of what you asked them to do, right? I mean, I pay $200 a month for OpenAI's operator. Did anybody else sign up for that stupid? And I tried it, right? I tried it, and it was horrible, right? I mean, like, I told it to make a tiny change to a Google Doc, and it went for 20 minutes. According to its report, it studied my doc for 20 minutes, and then it like cut one of my paragraphs in half, like randomly. That was the agent. So I don't think that agents that go off by themselves are going to be useful at all. I think you are all going to be managing fleets of agents just the way you manage fleets of libraries today. Yeah? I mean, think about it. All your dependencies you got to bring in, all the packages and version management and everything. It's going to be very similar with agents because they will be special purpose. They'll be able to do specific things like a code review or a security scan or whatever. And you're going to be wielding them as tools. But it's a pair programming exercise, unfortunately. It is a pair programming. And a lot of people don't get this, all right? Okay, let me tell you a story. Imagine you're a programmer and you've got some work to do, and your boss comes to you and says, "We brought you a new intern, all right? And this intern's going to pair program with you. They don't know our systems very well, so you're going to have to bring the context to them and get them up to speed, but they can work all day long, and here you go, all right? Have fun." And what a lot of people do is what I did with Operator. I try one thing, and it fails, and then I'm like, screw it. So let's imagine you go to this intern and say, "All right, before we get started, I'm going to give you a little test." And then you give the intern a project to do. And then they don't do the project very well. And you say, "This is garbage. I can't use this person. This isn't going to work out." Okay? Who does that? Nobody does that. That would be stupid, right? But that's exactly what half of engineers today, roughly, are doing with ChatGPT. They try one thing and they go, "It got it wrong. It's dumb." Right? This is a problem. You can't do this, all right? What you have to do is you have to use iteration, and you have to use prompting and a bunch of other techniques that I'm not going to talk about today. I don't want to bore you to death. You can read the book when we publish it. All right. I want to talk about how the role is changing. Okay. What's going to happen? Pavel have been talking about predictions. How do we predict as business owners, as employees of our companies? How do we make predictions about what's going to happen? I have professors reaching out to me from universities all over the world asking, "What should we teach?" I have companies reaching out to me from all over the world going, "What should we interview for?" Those are related, by the way. And we don't know, right? I mean, if somebody here thinks that they know, I'd love to hear your opinion about it. But right now, it's really difficult to predict because it's happening exponentially, and it's really hard for us to get our heads around exponential curves. Everybody kind of looks at them and thinks they're linear, but we're going to see really huge, huge changes. Okay, so the job is going to become very much like you've gone from a cook in a kitchen. That's what engineers are, right? Engineering is a workshop, right? You're building stuff. It's not unlike being, in a kitchen. You're moving from cook. You just got promoted to the head chef of a big restaurant, and you've got a bunch of automated helpers or whatever, human helpers, okay? And you're now managing them. It makes a lot of sense, right? It levels you up. Just like high-level programming languages leveled us up from assembly language. I spent my first 5 years, 1992 to 1997, writing 8086 assembly language, okay? Programming languages that had if statements and loops were a huge level up, right? And this is going to level people up to the level of a head chef. You are still responsible for the meal. You may not be cooking the individual pieces of it, but you have to assemble it into a cohesive whole, and you have to have some taste, right? So that's the new job. But that's not a junior job, is it? The more you go up in that task graph that I showed you, those higher level tasks have a tendency to be rather senior. The very top one is deploy our project, right? Of course, there's going to be a VP or somebody in charge of that, okay? So this is a complicated problem because those blue nodes are juniors, and moving, and so it's scary, right? It's like, are we in the same situation as surgery and legal? Junior engineers are going to have a problem, and I think the answer is no, but their role is going to change, and what it means to be a junior engineer is going to be very different, in 2 years or less. Okay, just like in computer graphics, okay. computer graphics I've watched for the last 30 years as all of the stuff that we had to learn as graphics programmers got pushed down into the hardware. So you just didn't need to know it anymore. I'm talking about like, right, rendering and Z buffering and all of the low-level primitives, polygon clipping and all that stuff. Hardware does it, or your engine, right? And so what you actually study as a graphics programmer over the years has gone higher and higher level in abstraction until graphics programmers today are working with custom physics engines and game design and scripting movies and things like that, right? It's a very different kind of a job. And they're much more productive now too, right? I mean, like, look at the graphics today compared to 30 years ago, right? I see the same thing happening here, all right? I really do. I think the role changes. I think junior engineers start to become, right out of the starting gate, more like architects, okay? And you have to learn how to rely on the LLM to do that, okay? So I'm gonna start closing out here. I just want to make sure that I haven't missed any really, really important points here. Hallucinations is a huge problem, all right? Hallucinations, is when the LLM tells you some bullshit, okay? Which happens kind of all the time. I'll tell you guys a cool story. This is a cool story. I heard this from Craig McLucky last week. He's one of the co-inventors of Kubernetes, and he's working on this product called StackLock that does, I'll tell you what it does. So apparently there are some North Korean hackers, okay, who have been doing something that's called hallucination squatting. All right. You guys remember domain squatting from the early days of the web when you could buy McDonald's.com for $5 and then gouge them for $1 million when they wanted it? Domain squatting, right? Just waiting for somebody to come along, and it's like a big spider, right? Well, hallucination squatting, check it out. LLMs will, because their training data is a couple months out of date, they'll give you package numbers that are usually a little old and have known security vulnerabilities, okay? And so what they do is they reverse engineered which versions and package names are the most hallucinated by foundation models. And then they set up packages that do the exact thing, but with malware in them that does remote code execution setup, okay? And then they put it up there, and then when the engineer sees a hallucination, they pull down the North Korean package that does the same thing, but also puts a rootkit on their machine, okay? It's craziness. It's craziness what's going on. So the output of the LLMs, the hallucinations have made this really, really difficult for us engineers, because we're used to our tools being deterministic. It's been this way forever, right? I mean, tools just, they either work or they don't work. But with AI, it's more complicated. And it's not even a situation where you can go, oh, well, one answer out of 5 is going to be wrong. It's not that simple. It's more like 5% of every answer is wrong. You know what I mean? It's like it's distributed strangely. That non-uniformity really bites us, okay? As engineers, you're going to get more help from the LLM out of stuff you don't know than from stuff you do know, but you're also going to get better help at things that it's better trained on. It's going to be better trained on JavaScript than it is on Rust, because it's just a function of how much training data is out there, right? So, this is such a complicated problem. But basically, like, devs, you and everybody else is going to have to start learning to deal with ambiguity a little bit better, right? And deal with noisy data coming in. And what that means is, fundamentally, I hope I have a slide on this. It's really important. It's really unintuitive. It's really challenging. It's a lot of copy and paste. It's a lot of manual work. Chat-oriented programming is really awful today. But it is going to be great within 2 years. All the tools vendors are working on it now. The models themselves are smart enough to make it work today, but the tools need to catch up. Because why? Because it doesn't matter if the AI knows that you need to go and run this command line tool. It can't do it. Well, actually, they can now, right? That tool, it's starting to happen. Right? Cody just released the ability to have this, and other agents are too. But the basic problem is using tools and integrating. That's the kind of thing that LLMs are not going to be good at for quite some time. But what you need to do, I can't believe I don't have a slide on this. No slide, but what you need to do is you need to double down. Okay, this is probably the biggest takeaway for this whole talk, is the thing that changes the most for us as engineers, interestingly, is that we need to get probably 5 to 10 times more rigorous about testing, because we're not writing the code anymore. And validation. Validation is an interesting one. Validation is different from verification. Validation is determining that it's actually solved the right problem for you. It may have got a perfect solution, but it's to the slightly wrong problem. And these things are, they're a skill. It's an art. It's something, it's an instinct that you develop over time. You develop these things. But if you're not doing it today, then you're not developing those instincts. If you're waiting for the tools to catch up, what's happening is the tools are gradually going to catch up, but the job changed. The tools are supporting the new job, not the old job so much, okay? Now look, are your skills as an engineer going to go away and not be important? Well, it is true that a lot of people are worried about skill atrophy, right? Skill rot. Like, for example, today, programmers don't really have to do very much bitwise arithmetic anymore. How many of you have set a bit in a byte recently with an XOR or something operator? No, right? We don't do that anymore. So like there are skills that are really important for a decade and then they actually do rot because nobody needs them, and that's okay. And so there may be some engineering skills that'll rot away, like, for example, having to know the minutiae, the tiny details of every programming language that you use. Right? You probably don't need to know that stuff anymore because, right? It's just like in the old days before we had compilers, and then the compiler comes along and it gives you the errors. You don't have to worry so much anymore because the compiler will tell you. Same thing goes with the AI, yeah? But it's such a different kind of a role that I don't think people understand how important testing is. But the nice thing is the LLM can write the tests for you too. And so what you do is you adopt test-driven development, TDD, whether you're using it before or not. I never used TDD before. All right. I was like, screw it. It's because every time if you write the test, now you've written the contract, but you're not sure if you've got the thing that you need, that iterative, that exploration, right? And so I didn't like TDD at all. But now I always do TDD. I say, write this code, write a test, or write this test and write a code. They happen at the exact same time. Okay. And that way, it's a little bit better, right? If you catch it early on, if you start doing your testing early, and then add more later into your CI/CD pipeline. I'm talking about have agents look at the code, right? Have humans look at the code. Then I think you're on the right path to getting validation. I'm sorry I didn't have a slide on this. Okay, so coding assistants. I'll talk about those briefly. There's lots and lots and lots and lots of coding assistants out there. How do you choose? Well, you should probably try a couple of them. They're like cars these days. They all kind of have the same feature set, but presented differently. So, Cursor has a beautiful UX. Cursor has really smooth context creation. I love Cursor, right? But, Cursor doesn't scale up at enterprise the way that Copilot and Sourcegraph do. And so if you're, at a really big company, Cursor may not be an option for you, right? And then there's other ones too. There's the JetBrains one that's built into their IDE, and there's coding assistants galore, right? The important thing is not which one you use. The important thing is that you're using one. Yeah? Okay, I got a last question. Who here is using a coding assistant today? Not ChatGPT or a chatbot, but actually using a coding assistant in their IDE. Oh my God, not very many. That's terrifying. All right, well, so that is my takeaway for you today. All right, is that this is changing. It's inevitable. It's going to happen over the next, say, 18 months to 2 years. You're going to start seeing crazy changes in how development is conducted, and you should be ready for it. Okay, don't ignore it. Don't put your fingers in your ears and say, la la la, this is all hype. It's a fad. It's going away. I see engineers still saying this. They say, I'm just waiting for this all crash and burn so we can go back to the way it was before. Folks, it ain't ever going back to the way it was before, okay? So take the time to study this stuff a little bit, yeah? Play with it and develop that feel, that intuition for how to get the LLM to do what you want instead of what it wants, right? Which is arguing with you. Okay, so with that, I'm going to tie it up and ask for questions. Yes.
Thank you for a great talk. You started with a challenge that I don't believe you answered to it during the talk. So generally speaking, how are we gonna get senior developers in 10 years where the path from junior developer is broken since last 2 years?
Got it.
I don't know if you watched Karate Kid, because Karate Kid for me is a great metaphor of how to become a senior engineer. Generally speaking, when you are junior, you do the shitty stuff. And you do the shitty stuff because it gives you the fundamentals. And how we're gonna get senior developers by growing developers without the fundamentals, and you literally said that junior developers will be architects, and how can they get? I don't get it, and I don't have the right answer to it. So
Yeah.
for yours.
Well, for starters, I don't know if anybody knows the answer. It's very hard to predict. But I believe that there will be more jobs than before for junior developers. I think that just like automobiles made everybody able to have transport when they switched from horses, everybody thought that automobiles would be a relatively niche thing, but it actually made it so that everybody could do this. Same thing goes for this. I think that pretty much everybody's going to be able to code. Everybody's going to be an engineer at some point, right? You're going to be able to like make your own applications even if you don't know very much about code. So in that sense, right? I mean, like what is a junior engineer? It's somebody who can write code, somebody make things happen. My feeling is that what it means to be a junior engineer in the future is you learn computer science and then you learn agents, right? There's going to be 1,000 agents to choose from, in a couple of years, and you're going to learn how to use them to get them to do the work that you need done. And then your training in computer science and software engineering is going to allow you to operate at those higher level task graph nodes and say, all right, I've learned that I can't trust these LLMs, that I need to cross-validate across the LLMs, that I need to do extra testing and validation. You've learned all of the techniques that right now are just kind of like tribal knowledge, black art stuff, right? You'll learn it in school. They'll teach it to you, right? And then you come out, you're a junior developer, but you're not really writing very much code. That's my feeling. It could play out completely different, though. You want a follow-up question?
You say that junior developers will learn it, but how can they learn it if this generated code will be a black box on their path to seniority?
You work with black boxes all the time. Black boxes are how we evolve as software engineers. Black box is good, all right? Now, whether you can trust that black box or not is a real different question today. But think about it. All the libraries that you use are black boxes.
But what you're saying is that I can be a Formula One driver while my whole experience is driving a self-driving car.
Yeah, so I mean, look, the timeline here to where we get to the point where a Formula One driver could launch an app is 10 years, right? But, it's going to happen at some point. Engineering is just going to be so different. You're not going to be writing code, okay? The reality is scary. I mean, I'm pretty good at coding. I've written over 1 million lines of code in my career. And, the LLMs are frighteningly good, right? They're getting better and better and better at it. So you're right? You're completely wasting your time and the company's time if you're trying to do it yourself at that point. I'm an optimist. I really think that it's going to be good for junior engineers. I think they're going to love it. You don't have to worry about, how many times have you spent time debugging an off by one error in a loop? Come on, man, that's not a good use of your time, right? I think the future is very bright. It's going to be rocky, but I think it's bright, personally.
I have a question. How we will invent something new with AI if AI will do all work?
Okay. How do we do something new if the AI is doing all the work? So I mentioned this briefly earlier, but I'm going to come back to it. There's one thing that the AIs don't seem to have that you do have, which is taste. Okay, this is actually a problem in the industry. How many bad video games are there out there that are actually quite competent technically, but they're a bad game? Or how many bad movies are there that are technically very competent, but they're a bad movie because somebody lacked the taste to bring it all together? This is why I use the head chef analogy. How do you build a new meal as a head chef, right? And I think that you're going to use the LLMs, you're going to lean on them and get ideas from them. But ultimately, it's you. You're responsible. And even no matter how high up in the chain you are, right? You're using AI, whatever you're using, you can't blame them. You have to blame yourself. I mean, you're accountable for the work that you produce with AIs. And so it's no different than before, except that you can now be more creative than before. You see, it's going to give us all more resources to be more creative. And so I think we're going to see an explosion, right, of creative new stuff because of this.
And I think last question was here.
What after agents?
What's after agents? We all start worm farms.
Singularity.
AGI? I don't know, man. I try not to think that far ahead because that's scary. All right, cool. Thank you, everybody.